So when you have like separable differential equations, and you want to find out the general solution, like let's take an example where let's say dy by dx is xy. Suppose this is the general equation that has been given. Now you notice here is that there is a y term as well in the right hand side. So this is not, you can't just integrate the both the sides directly. So in this problem, when you're doing the general solution, you need to isolate the y's one side. So it's always try to bring in the y terms one side and x terms one side, x terms one side. So now let's say when you are solving this differential equation, it will be dy over y equals to dx, x times dx. So you can just bring in y down and you can move dx here. So at the end, what we get is dy over y equals to x times dx. Now, in this case, this is what I was talking in the beginning, is that, okay, you integrate both the sides. You'll have to integrate both the sides, but obviously you can put the constant of integral only one side. So when you're doing this, now integration of dy over y is obviously, we know that it'll be ln y, and integration of x is going to be x squared over 2 n plus c. So now when I get rid of the absolute value of ln term, so absolute value of y will be e to the power of x squared over 2 plus c, and then it'll be y equals to plus or minus e to the power x squared over 2 plus c. And of course, this is still, you don't know the exact value of the particular solution, so they haven't specified anything. So we have all the freedoms to simplify what we're getting in terms of redefining another constant. So like plus or minus, I can break this down as e to the power x squared over 2 times e to the power c. And then I can take, let's say, plus or minus e to the power c as a new constant, let's say capital C. So my general solution for this equation becomes c e to the power x squared over 2, where c is nothing but plus or minus e to the power c. And now in particular case where they have given certain x and y values, you just plug in x and y here to get this c. You don't need to go backwards to find the small c, just because eventually you're just finding other general solutions, so you don't need to go back and find what is a small c. So this is how you find out the general solution of the differential equation, which is separable. So in this another example, what we have is basically x squared plus 5 times dy by dx is 2x over y squared. Suppose is our differential equation for certain problem. So once again, you separate the y's one side and x one side. So bring in y squared here. So y squared times dy, and bring in x here. So it'll be 2x over x squared plus 5 times dx. Now if I integrate both the sides here, so y squared integral will be y cube over 3 equals to, now in this one you can either use substitution technique, or just you can simply use integration of f dash x over fx, which is nothing but the ln fx. So ln fx is nothing but ln x squared plus 5. So it'll be ln x squared plus 5. Anyway, x is positive, so you can just ignore absolute value, and plus c. So your final integral in this final function will be y cube equals to 3 ln x squared plus 5 plus c, and then you take cube root of this. So cube root of this will be the exact function that we have got. So now, since they haven't given any boundary condition or any limiting condition, what we're going to take is, we are not going to find out this particular constant. This is how we're going to leave this expression. So our general solution in this case is y is cube root of 3 ln x squared plus 5. And of course, you can take this as plus 3c, not only 3c, because if you multiply here, it'll be 3c. And you can define this 3c as another constant. That's what exactly I had done earlier in my mind. So it'll be, this will be capital C, you can say. So cube root of 3 ln x squared plus 5 plus c, that's going to be your answer. Now for the b part, once again, first separate the variables, bring in 1 minus y down here, and dx over root of 4 minus x up on the other side. Then you integrate both the sides. So integration of this is pretty easy. Just modify the structure before you integrate. It'll be 4 minus x to the power negative half dx. Now you integrate this. So this will be ln absolute value of 1 minus y over negative 1 equals to integration of this will be 4 minus x to the power negative half plus 1, which is half, upon half, and then divide by coefficient of x, which is negative 1, and plus c. So that's your normal integral here. So it'll be ln absolute value of 1 minus y equals to, this is nothing but negative 2 square root of 4 minus x plus c. And then, of course, you can make y the subject of the formula and all. So it'll be absolute value of 1 minus y will be e to the power negative 2 root 4 minus x plus c. And then it'll be 1 minus y will be e to the power negative 2 root 4 minus x. And I can break this down, and plus c will be plus or minus here. So once again, like for the previous problem, what we did is 1 minus y is plus or minus e to the power negative 2 root 4 minus x, and plus, break it down as e to the power c. You can take this as a new constant, plus or minus e to the power c as new constant. So your y will be equals to 1 minus new constant e to the power negative 2 root 4 minus x. So this is your general solution of this particular equation. So after you integrate this part, if you cross multiply negative 1 here, so you'll get, this was negative 2, so negative 1 become positive, and obviously this can be a constant negative c here. And after that, you take up in the power if you get rid of ln, and so you'll get plus or minus e to the power 2 root of, you can just remove plus, it's 2 root 4 minus x and minus c. And if you break this down, e to the power negative c plus or minus can be taken as another constant, and if you make y the subject, this will be your general solution for that particular equation. So for the c part, basically what we'll do is once again separate the variable. So it'll be y dy over root y equals to 6x over x squared plus 5 and dx. So y over root y is nothing but root y dy equals to integration of 6x over x squared plus 5 dx. Now in this case, it'll be y to the power 3 over 2 divided by 3 over 2. That's the integral of this. Will be, in this case, you can see this f dash x, but like you can take 3 outside. So 3 times 2x over x squared plus 5, which is like f dash x over fx format. Fx is in the denominator and f dash x in the numerator, so it'll be ln 3 ln x squared plus 5 and plus c, we can say. And of course, then you make y the subject of the formula. So y will be y raised to 3 over 2 equals to 6 over 3 ln x squared plus 5, which is obviously 2 here, and plus 3 over 2 in this case. Just a minute. So when you make y the subject of the formula, you bring 3 by 2 other side. You can take this 3 by 2 as another constant, like maybe any other constant you can define, and then you take this power other side, it'll become whole to the power 2 by 3 then. So that's how you do this question. Now let's take one example where it requires logic of partial fraction to do that problem. So in this one, what we do is basically first step is the same, isolate the variable. So bring in, I took y squared common and got it to the other side. So it becomes dy over y squared equals to 5x plus 4 over x squared plus x minus 2 as it is. And I got dx other side. So up till this step, we have got our separation of variable done. Now you integrate both the sides. So if when you're integrating 1 over y squared, take it up and make it y to the power negative 2 and integrate this. Y to the power negative 2, if I integrate, it is going to be y to the power negative 1 over negative 1. But the other one is a little tricky, which needs to be taken carefully. And you can see that since I can factorize the denominator, it could have been done by um, partial fraction technique. So what I do is 5x plus 4 over x squared plus x minus 2. First, I factor out the denominator, which comes out to be x plus 2 and x minus 1. Express this as a partial fraction. So it'll be a over x plus 2, b over x minus 1, assuming that you have the knowledge of partial fraction, and solve for a and b. So if I solve for a and b by plugging x as, um, once I plug x as 1, once I plug x as -2, you get the value of a and b to be 2 and 3. So plug a as 2 and b as 3. So the same integral that is here can be replaced by this, which can be integrated easily. So which is 2 ln x plus 2 and plus 3 ln x minus 1 plus c. And I got minus one other side. So you get this one. You could define this as a new constant, positive capital C or something like that. And if I reciprocate the expression both the sides, I get the y as the subject of the formula. And now in none of the problems we did to find out the exact solution. In lots of cases, you will be given the initial condition like x is 0, y is 1, find out the exact constant. So that can be done easily like the normal integration, like in the normal procedure what we followed.